Hi everybody, it's Mr. Gerhard, and we're going to go through and show you a couple of examples here of how to solve quadratic equations using square roots. We did a couple of examples in class, and this is going to be 4 more just because we went through it kind of quickly, and hopefully this helps. Feel free to leave a comment and let me know how this goes. So here we go. First couple problems that we have. The first one is this z squared equals 7, or z squared minus 7 equals 29, and the key to doing any of these is to go through and get the squared part by itself. So right here, the z squared is our squared term. And so we can use this because there's no other z term, just the constant term and the squared term. So I want to get that squared term by itself. When I do this, I'm going to go ahead and I'm going to add 7 to both sides. And I'm going to get z squared equals 36. Now, to undo a square, we square root. So I'm going to square root the left side and square root the right side. And whenever we use square roots to solve an equation, we have to use plus or minus. So what I get is I get z equals plus or minus the square root of 36. Now I'm almost finished, but since it's a square root of 36, I need to simplify that a little bit more. And the square root of 36 is just 6, so I get z equals plus or minus 6. And that's my answer, and that's my solution. If I were to plug it back in, I could say 6 squared minus 7 is 29, or negative 6 squared minus 7 is 29. Either way it works, and those are both the solutions to that problem. Over here we have another one, a little bit more detail in getting the x squared term by itself. But there's the x squared term, and I need to get rid of the 5 and I need to get rid of the 3. So I'm going to go ahead and I'm going to subtract 5 from both sides. Subtract 5 from the left, subtract 5 from the right, and I get 3x squared equals 36. Alright, that's good. And then I'm going to divide by 3 because I need to get the x squared by itself. And so now I get x squared equals 12. To undo the square, we square root. So I'm going to square root the left side. I'm going to square root the right side. And now I'm going to get x equals plus or minus the square root of 12. Now 12 is not a perfect square, but we do know that 4, which is a perfect square, goes into 12. So I need to break this down and simplify it and say the square root of 4 times square root of 3, because 4 times 3 is 12. Square root of 4, that's our perfect square. That's 2, so I get plus or minus 2 square roots of 3. That's what x is equal to. I could again check my answer by plugging it back in to the equation, and when I do that, I would see that it is correct. Alright, now 2 more examples here. The first one, these are now kind of looking like vertex form or some of the problems and equations that we had worked with before. But now the squared term is this part right here. So in order to get that by itself, I need to actually get rid of the 3. Since 3 times quantity x minus 2 squared, I'm going to divide both sides by 3. When I do this, I get x minus 2 squared equals 9. Well, how do I undo the square? Square root. Square root the left side, square root the right side. And what I get then is x minus 2 equals plus or minus the square root of 9, which is 3. Last part, get the x by itself. I'm going to add 2 to the left, add 2 to the right, and I get x equals, now it's 2 plus or minus 3. What's 2 plus 3? Well, that would be 5. And 2 minus 3 would be negative 1. And so x could equal either 5 or negative 1. And when I have that straightened out, that is my answer. And now on to our last problem. Last problem reads 2 times the quantity x plus 2 squared minus 5 equals 8. So I need to get this x plus 2 squared by itself. And so I'm going to first add 5 to both sides, giving me 2 times the quantity x plus 2 squared equals 13. Then I got to divide both sides by 2 to get that x plus 2 quantity squared by itself. So I get x plus 2 squared equals 13 over 2. Leave it as 13 over 2. Don't reduce it to 6.5. All right, and then we square root both sides. Square root the left, square root the right. When I do that, I get x plus 2 equals, let me write that better, x plus 2 equals, whoa. All right, so we got x plus 2 equals plus or minus the square root of 13 over 2. Now we can't have a fraction in the radical, so we got to split that up. It's going to be plus or minus the square root of 13 over the square root of 2. I can't have that radical in the denominator, so I'm going to multiply by the square root of 2 over the square root of 2. And that's going to give me plus or minus the square root of 26 over 2. And over on the left side here I have x plus 2. And I finally just subtract 2 from both sides, and I get x equals negative 2 plus or minus the square root of 26 over 2. And that's our final answer. What that allows us to, it kind of looks kind of funny because it's negative 2 plus or minus the square root of 26 over 2, but it is the final answer. It allows us to see that, and we're good to go. When you're going and solving quadratics that just have an x squared term or has something in this like x plus 2 squared like we do here, or x minus 2 quantity squared there, we can get that squared term by itself, take the square root of both sides, making sure that on the right side you do plus or minus the square root, simplify, and get x by itself, or the variable by itself. So I hope this helps. Make sure to do those homework problems tonight, and we'll see you later.